So this is 3.3 number 7 and from pre-calculus 20. And the question asks, for each quadratic function, and we'll do A together, determine the maximum or minimum value. So this really is the y value of the vertex. Okay? And if you think about any parabola, whether it opens upwards or downwards or whatever, the maximum point of a parabola that opens downward would be the y value of the vertex. And the minimum point would be the y value of the vertex. So we're looking for the vertex, or at least the y value for the vertex. So 3 different ways you could do it. One is just to graph it and then determine the vertex. That's easy. Anybody can do that. We're not going to focus on that because you're going to need to be able to do this algebraically. So there's 2 different ways you could do this algebraically. You could find the x value for the vertex by doing negative b over 2a. You guys remember that? Negative b over 2a. So the x value of the vertex is going to be negative 5, which is, this is a value is 1, b value is positive 5, c value is positive 3, right? So you get negative 5 over 2 times a. So that's negative 5 over 2. That's the x value for the vertex, negative 5 over 2. Does this one open up or down? Does this open up or down? Whoops, that's the next thing we got to figure out. Sorry, did someone say? Up. Okay, well, everyone should know that right away. It opens up because we have an a value of a positive 1. So negative 5 over 2. So I don't know where the y value is yet, but it's going to be a minimum value, okay? It's going to be a minimum for a because it opens upwards, so we have a bottom, right? So it's going to be a minimum. Now, in order to find the y value, we simply solve for y. F of x is the same as y, and we plug negative 5 over 2 in for x, wherever we see x. And we evaluate. So the y value that's associated with the x value of negative 5 over 2 is going to be 25 over 4 minus 25 over 2 plus 3. And again, we could just pump this into our calculator, but you know what? We're looking for comfortability working with exact values and with fractions. So let's practice working with fractions. So we want to make sure that we have a common denominator for all these. So let's make this over 4. So let's make this 50 over 4. And let's make this over 4 as well. So that's going to be 12 over 4. That's what 3 is. So if we do all that, 25 minus 50 is negative 25, plus 12 would be negative 13 over 4. Okay? So someone can check at the back of the book there the solution manual, just to make sure we haven't missed a sign or something. But it appears that the y value is going to be negative 13 over 4, and that's going to be the minimum. Does it look like that? Yeah? Okay, so the minimum value is negative 13 over 4. Now, that's one way. That's the second way. Graphing, second way, using the negative b over 2a to find the x, then find the y. The third way, which I'll show you now, is to complete the square and get it into vertex graphing form. And when we get it into vertex graphing form, you can just see the y value there, and that'll be good. So let's practice that. All right, so I'm going to group together these two terms. There's already a 1 there, so I don't have to factor anything out. That's great. So I'm going to go x squared plus 5x plus blank. I'm going to end the bracket there because this is going to be my perfect square in here. I'm going to leave that plus 3 out there, and I'm going to subtract blank. I added something to this side, and I need to subtract the same thing to make it still an equation, right? So I haven't affected it any. So what do I do? Well, how do you find this number? Anyone remember? Want to shout it out? How do I find this number right here? Divide by 2. What do I divide by 2? Yes, 5x. Well, I just focus on the number, but yeah, the 5, you divide it by 2 and you square it. Okay, so that's 5 over 2 squared is going to be 25 over 4. Okay? By doing that, I've added 25 over 4, so I need to subtract 25 over 4 outside. And so this is going to give me now a perfect square binomial. It's going to be x. That's a plus. This is a plus. What did I, well, half of this is 5 over 2. That's what I squared to get this. So it's 5 over 2. And then what do I do here? Well, I have to combine like terms. So this is actually plus 12 over 3 minus 25 over 4, 25 over 4. So 12 minus 25 would be negative 13 over 4. So this is how we complete the square, and now we have vertex graphing form. You can see the vertex is negative 5 over 2, which we found that was the x value before, and negative 13 over 4. That's the y value for the vertex. It shows up in that form. Because it opens upward, we know this is going to be a minimum. And so that's the third way that you could do this, okay? So graphing, look at the vertex. If you have to do it algebraically, you can use the x equals negative b over 2a, find the x value, plug that value into the equation to find the y value, and then that's your minimum or maximum. Or you can change the whole equation into vertex graphing form and look at the constant that you end up with out here, and that's the maximum or minimum. Okay? So I know I went through that pretty fast, but if you get that, great. If you don't get it, ask me a question. This is also 3.3, and this is number 22. So, as I mentioned to some of you already, this is a real calculus type question, and if you have a handle on all the other stuff, honestly, you should pay attention to this question, because this is sort of next level. So if you're like, yeah, I got a handle on everything here, I want to know what this question is about. It's a tough one. This is a calculus type question. It talks about maximizing area. And that's a concept in calculus called optimization. And so you're a couple years away from calculus yet. And we won't use calculus methods here, but I will tell you how this looks algebraically. So when you kind of get to pre-calculus 30, when you get to calculus 30, maybe this is a little bit easier to handle when you get there. So what this involves is we have to take the information that we're given. We need to make an equation. Then we need to make another equation and merge the two together so that we have some, we're going to have a parabola, and we're going to find the maximum point. Because look what the question says, what measurements will maximize the overall area? So when we maximize something in calculus, or in pre-calculus here, we want to find what's the maximum value of a function, of a relation, of a graph. And so that's what we've been working with, right? Vertex, maximum values. So let's set this up. What we're given is a diagram here, and all these dotted lines are going to be fences. Okay? That's fence material. There's a total of 900 meters of fencing available. So guess what? That's our first clue as to how we're going to start this. 900 meters is made up of x plus x. There's another x over here, x, another x over here. So far I have what? 4 x's, right? So 4 x's. And how many y's do I have? Well, I have 1, 2, 3 y's. I have 4, 5, 6 y's. I have 7, 8, 9 y's. What we haven't taken into account is this. So what length is this? That's the same as this one. So I actually have 2 more x's. And then I've got everything figured out. Okay? So this is going to be 900 equals 6x plus 9y. Okay. Use the 2 variables, no problem. When we actually get to a function that we want to examine, it's got to just have one variable, right? Or y equals something x. So what's next? Well, we want to maximize the area. So that's one equation. The second equation is the quantity that we're trying to maximize or minimize. And that's going to be the area. The area is given by the length times the width. So that's going to be 2x times 3y. That's what the area is, or a equals 6xy. So I've got my material here, I've got my area here. If I want to maximize the area, what I want to do is I want to examine this function. Well, right now it's not a function, is it? It's not a function at all. It's got 3 variables in it, 3. So I only want 2. I want area on one side, but then I want everything in terms of just one variable on the other side. So then I can kind of graph it. So what we're going to do is we're going to merge the 2 equations. We're going to combine them. And you did this in grade 10. You did this in grade 10. What we're going to do is do substitution. Okay? So let's solve for y here for this equation. That's going to be 900 minus 6x equals 9y. Then we're going to divide everything by 9. We're going to get y equals 100 minus 2x over 3. Okay? And I would suggest putting the x in the numerator, in the top with the number, instead of 2/3 and then an x on the side, because then it kind of like, if you don't write really neat, or it could like, where's that x, on the top or bottom? So just put it on the top, okay? It'll make things a bit easier. So why did I do that? Well, I did that because this is the equation we want to focus on, want to maximize area, and I have a y in there. So if I could replace y right here with something in terms of x, that would be great. So this expression right here includes the information about the amount of fence I have. Okay, now I know this is a lot, okay? It's a totally different kind of question than we've done before. But this is sort of how you do this. You take the information and you want to merge two things together, two equations to make one. So the area is going to look like this, and I'll try and change my color a little bit. Area is going to be 6 times x times 100 minus 2x over 3. See that? 6x y. What's y? Well, y is this. All right, and let's expand that out to see what we're going to have. 600x minus 12x squared over 3, right? When you expand this out. So the area is actually going to be equal to negative 4x squared plus 600x. And here we now have an equation that's a parabola. The x is going to be part of the one dimension of the triangle, and the a is the area, right? So if I want to maximize area, what I'm going to do is I'm going to find out what the maximum value of this graph is. The area is going to be the y-axis, and the x is going to be the x-axis. And what I want to do is I want to graph this parabola, or find the vertex of this parabola. It's going to open downward. It's going to have a y-intercept of 0. Okay? And we can pretty easily now either change this into vertex graphing form or use the x equals negative b over 2a and find the x value of the vertex. And that x value is going to give us the maximum area. Okay? So I was helping someone with this yesterday, and I realized this is kind of an advanced problem probably for some of you guys right now. So if this is going mostly over your head, don't feel bad. You've got another 1.5 to 2 years, okay, before you have to do this for real, and then calculus methods on top of it. But this, if you can kind of get some of this in your head and see how, especially at this point, how the area is representative of the y value here, right? And the maximum area will come when x is a certain value here. This is the x we're looking for. That will give us the maximum area. This x over here will give us not the maximum area. This x over here will give us not the maximum area. But this one, the x value of the vertex, will yield us the maximum area. Okay, so negative b over 2a, that's going to be negative 600 over negative 2 times negative 4. So what's that going to be? That's going to be 600 over 8. What's that? 600 over 8 is what? 75? Is it 75? 600 over 8? Yes? 75? Yeah, 600 divided by 8, 75. Okay, 75. What that means is that the x value of 75 should give us the maximum area. But the question asks for the dimensions. So I need to know overall what's the length and what's the width. So I've got x, and if this is 75 and this is 75, the whole dimension over here is going to be 150. Everyone see that? 2x. Now to find y, we can plug x into one of our original equations right here. I have how x and y are related. through this equation right here. So, one more step. 900 equals 6 times 75 plus, how many y was it? Plus 9y. So 6 times 75, 2 is 150, 3 is 6, 450? 900 equals, is that right? 450 plus 9y. 900 minus 450 is 450 divided by 9 equals y. So y equals 25? 50? 50. 50. Thank you. Okay, so y is 50. Y is 50. X is 75, y is 50. So what's 50 plus 50 plus 50? That's 150. So we have the maximum area when this is a square of 150 by 150. So the dimensions are 150, what is it, meters? By 150 meters. That's the end of the question. A long one. Does anybody have any questions right now? Or was that just a torrent of information that left you feeling tired? Anybody kind of get this? Anybody? I'm seeing some heads nod. I'm seeing most heads shake. Okay, no problem. Anyways, there you go. So yes, I assigned that question to see if anybody would have any idea how to start. But that's a big long question, isn't it? Okay. All right. Those are your two questions from 3.3 that you had trouble with. All right. Okay, so just a quick note on 17, anybody that's interested here. I won't do it all. I want you guys to do this one, but I'll set it up for you. So we're talking about a parabolic microphone dish, and it collects sounds. We talked about this already. Here's the equation right here. This equation, notice, has a y-intercept of 0, so it passes through the origin. And so that's really handy because the dish is going to look something like, this. It's going to pass through the origin. And is it, yeah, it's a positive, it's a positive value, so it actually goes the other way. My bad. Come on now. So it goes like this. So what they're asking you for is the maximum depth. They're just asking you for the y value of the vertex. That's all they're asking you for. So you can complete the square, or you can do negative b over 2a, plug that value in, get y. That's kind of it. Okay? So find the y value of the vertex for this function right here. Negative b over 2a will give you the x value of the vertex. Plug that x value in for x to solve for y. Or you can graph it and look at the vertex, or you can complete the square. I think that's all that it's looking for, though. It does say use an algebraic method, so you can't just graph it, I guess. So complete the square or negative b over 2a and then solve for y. And if you're still having trouble with that, I'll come and help you a little bit later, but that's okay. That's the start.